In the previous video, what we did was we took a look at the basic MATLAB environment and we learned how to open MATLAB and do some really simplistic commands. What we're going to do is we're going to take that a step further and we're going to start taking a look at some of the built-in commands in MATLAB. So one of the most important ones that I like is the CLC as well as the clear all operations. And I'm just going to execute those really quickly just to show you why they're important. So for instance, let's say we have just a basic environment. And remember we had like 33 plus like 46 or something like that. And then we had like another one, maybe we had something like 456 minus 899 or something like that. And I ran it. And notice we have the output, which is great. But then each time I run it, notice what happens is that in the command window, I still have all the previous iterations. All right. So what you can do is you could start each file, and I'm going to, with CLC. And what that does is that it clears out the command window each time you execute. So notice what happens is each time it only puts the most recent instance of the execution. So I'm just going to run it. And let's say I get rid of this one, and I'm going to run it. So CLC gets rid of everything. And I also like to use clear all, because sometimes what happens is that sometimes there are some values stored in variables. And unfortunately, that sometimes carries over. And so if you clear all, that'll clear out any variables. And later in the course, when we start doing a little bit more intricate operations, we want to make sure, especially with symbolic variables, that we clear them before we do anything else. All right. So what I would suggest is each time, just start each of your files with CLC, hit enter, and then type in clear all. Right. Now, these are all the built-in commands. We already saw CLC, but if we want to recognize, or if we want to represent pi, we use lowercase pi. And I want you to notice that all of the different built-in functions start with a lowercase letter. This is important. So for instance, let's say I want to define something like the sine of pi. And I type in sine of capital pi. Now we know sine of pi is going to be 0, but if I run it, then notice what happens is it says unrecognized function pi. All right. So I have to make sure that this is a lowercase p and a lowercase s. I also have to make sure that when I execute this, that I want to make sure that I use the correct set of parentheses. I also want you to notice down here that it gives you the answer as 1.2246. And then this is the scientific notation, 10 to the minus 16. It's almost 0. All right. If we want to, we can go ahead and say something like cos of pi. And I can run that, and it gives me -1. All right. So sometimes when it gets really close to 0, MATLAB has some truncation errors on occasion, or just some round off. So just be careful when you're doing that, just to make sure that you understand that sometimes it expresses 0 in scientific notation. All right. And sometimes you will get a 0 out of it. But if you get something like this, where you have an e to the minus 16, that just means that you have 0 there. All right. Or really close to 0. If you wanted to do an exponential, so let's say e to the 5th, I would just type in exp of 5. Right? And this just represents the value of e to the 5th power. And if we go back, we can see that we could just go ahead and type in a whole bunch of our different trig functions. So we have like our arc sines. So for instance, if I wanted something like arc sine of 1, all right, if I execute that, that gives me 1.5708. We might have to get that into a symbolic variable. So I can use sim a sine 1, and I can run that. And it might give us the symbolic variable, it might not. And notice it gives us pi halves, the exact value. All right, so if I don't use sim, if I just use a sine 1, then it just gives me the decimal representation, which isn't all that impressive. But if I use something like our sib, all right, and let me just change this to, let's say, square root of 2 over 2, just so that way we can have something different. All right, notice it gives us pi 4th out of this. All right, so that's pretty cool that we can go through and use MATLAB to do some of these trigonometric or inverse trigonometric sorts of things and couple it with the sim function. All right, so I'm going to go ahead and work through some of these exercises that we have. And a really basic one, 75 plus 27 minus 33. Right, so we have our 75 plus 27 minus 33. And let me make sure that I just typed in the right numbers. All right, and I'm going to go ahead and run this. And remember, if you ever get pushed off of the run, if you accidentally click up here, remember you want to click on editor. All right, editor is going to go through and you can run it. And here's our answer. All right, another example is to find the absolute value of e to the third log base 7 of 25 minus 420. So just like a calculator, what I would do is I would start out with the absolute value, and we want to look on our sheet, and we look up here and we don't see absolute value. So if we ever need any help, what we can do is we can go to MATLAB, and in the upper right hand corner, we can go ahead and just type in absolute value. And usually what will happen is it'll come up with the actual function. All right, now I'm going to click on this just to show you what happens. And if I click on it, a help file will come up with the MATLAB documentation. It might take a moment, but it gives you just some examples. All right, so if you assign abs minus 5 to y, then you get y equals 5. All right, so pretty cool that you can go ahead and just type in the help right up here if you need it. All right, now back to the original problem, we had the absolute value of e to the third power. So we know that e is exp parenthesis n, and in the case n is 3 because it's third power. So we're going to have exp of 3. And then we had this log base 7 of 25. And to get a log base 7 of 25, we're going to use the change of base formula. So we're going to say log of 25 divided by log of 7. So we're going to say plus log of 25 divided by log of 7. And from that, we're going to subtract 420. All right. Now, I want you to notice that if there's ever a red underline, you can just highlight that underline. And notice it says that we might be missing a closing parenthesis. So I'm going to close that out. Right. And it gets rid of that red. All right. Now, certainly you can underline, you can just hover over this one. And it says using clear with all decreases code performance, which is true. And it is often unnecessary, but there are times where it is necessary. So, so I'm just going to go ahead and execute this. And it gives us this number right here, all right, which is the approximation. If I want to ramp up the difficulty a little bit, I can go ahead and try to evaluate this animal, which I will. So that now I'm going to be careful because in MATLAB, if I type 2 sine of pi over 2, and I'm just going to type it in 2 sine of pi over 2, which looks completely okay. But notice that there's a red underline. It gives you a parse error. And what that means is that you haven't, in this case, you haven't defined it's 2 times the sine. All right. So for multiplication, you're going to have to use this asterisk. All right. If it says terminate with a semicolon, you can ignore that. All right. If you want to, you can. But notice if I run it, and I know this isn't completely the problem, it gives me 2 as my answer. But if I forget that multiplication symbol and I run it, it gives me the error. All right. So a lot of times you have to spell out the multiplication from MATLAB to correctly give you the output. So just be careful with that. All right. Now going back, we have 2 sine of pi halves plus 4 cubed minus arctan of 0. All right. So I'm going to say minus 4 to the third power. And I think it was minus arcsine of 0 or arctan of 0. And remember, arctan, you just go up here and you have a tan of x, or in this case, x is 0. So I'm going to say minus a tan of 0. Now that's our numerator. And just like we would in our calculator, we're going to put this in parentheses and then divide. And now in the denominator for this, we're going to have e to the 0 plus 32 sine squared of 2 plus 32 cos square of 2. All right, so in the denominator, I'm going to put a parenthesis. We know e already is exp of 0 plus 32 times parenthesis sine of 2 close parenthesis square. All right, so in MATLAB and in most programming languages, if you want to square a trig function, you evaluate the trig function and then you square it. All right, plus 32 times parenthesis cos parenthesis 2 end parenthesis, end parenthesis, square. All right, so notice what this is doing. This is squaring the cosine of 2. And notice that this is still red underlined. It's because I haven't closed out this last parenthesis right here. So I'm going to close that out. Right? And then I can just hover over this and it says to terminate with a semicolon. So I'm going to run it and it gives me this approximation. All right, so that's how we can go through and we can just utilize MATLAB to do some of the basic built-in functions to be able to operate on some of our mathematical sorts of expressions. Now, of course, we want to format the output sometimes. All right, and so what we're going to do is we're just going to go ahead and in the next video, I'm going to show you how to format the output for these. Maybe if you want to change the decimal places or if you want to print out a message as to what the answer might be.